are aligned, and they are attracted to each other but keep a small distance away. Shoals and flocks form on the screen when these three basic principles are applied. In nature, fish shoal close together, about a body length or less apart. Birds leave 3 or 4 body lengths between them, but the models for both are exactly the same. But this gentle drifting changes dramatically when a predator enters the scene. Now things look much more elaborate, but in fact these are just the same basic rules, with one obvious addition. When a predator attacks, get out of the way. On the model, we can see the point of impact where the predator enters the group. Just here, the rules are broken and individuals scatter away from danger. But as soon as the predator moves past, the rule of attraction brings them back together again. This constant splitting and reforming looks like the group thinks is one. But in fact, it is no more than a collection of individuals acting selfishly to protect themselves. Because the individuals at the point of attack scatter away from danger, the resulting patterns are always different. So on the computer screen and in nature, we see many beautiful variations. But the beauty has a point. As a peregrine dives through a group of starlings, shockwaves spread out. Seen again, the flock is being attacked from both sides. The waves of panic are quickly transmitted to birds half a kilometre away. And once the current danger has passed, there are many good reasons to stick with the crowd. An attacker is confused by the sheer weight of numbers. There are many eyes to spot danger coming. And the chances of being the unlucky one are much lower than in small groups. Flocking and shoaling normally means that more of the prey survive, but if the predator is big enough, this can work the other way. There is one predator that has learnt to encourage its prey to mass together. These herring are in a loose shoal. They are relaxed and calm, feeding on plankton. The sound of approaching danger spreads through the water. fish know they are in trouble and dive deeper to get out of the way. But they are swimming straight into a trap. Because humpback whales have a method of fishing as precise as any military maneuver. One whale dives to find the shoal, around 35 metres down. It circles the herring, flashing its white fin to herd them into an even tighter ball. But it's hard to control the panicking fish alone. Other group members arrive to help, and the job becomes much easier. The whales deploy their next tactic. Seen from below, the first whale underneath the shoal emits an incredibly loud noise. The call is as loud as a jet engine, 180 decibels. To fish, with their acute senses, this must be unbearable. Frantic and terrified, the fish are driven upwards at around half a metre a second. On the surface, bubbles appear, marking the next phase of this mass synchronized attack. "17 metres below, a single whale blows out a stream of air. Turning in a clockwise circle, it creates a curtain of bubbles. The humpbacks force the fish against the enclosing wall, increasing their speed to 3 metres a second. By the time they reach 5 metres below the surface, the fish are trapped within the bubble prison. There is no way out. Now the whales join forces for the kill. Air explodes from their blowholes, propelling the fish to the ocean's surface. This is the ultimate mass attack. By working together, humpbacks can wipe out thousands of prey in one go.